Yes,
Okay. Okay,
I've
that
not tried it
saves you a
before,
lot
but
of
we can.
stress. Yeah, so more homework for you guys now. Okay, so I've started recording. I'm going to mount my drive now. Okay, so now there are so many ways to this thing. Um, I'm trying to think, okay, which way do I want to use now? That will be very simple, and yet it is going to give us a very good score that will take us somewhere good on the leaderboard. Okay, I'm thinking, should I use the normal conventional way of having your train test plates and the rest, or okay, yeah, I know what to do then. Yeah, okay, okay. So now I don't know how it is for you guys in R, but for Python, the very first thing you need to do is you need to import your packages, your libraries, and all those things you'll be making use of in Python. So the very first thing I'll do is, okay, I love commenting my code so that it is readable. Yeah. Okay. So okay. Then the next thing I'm going to do is um okay, I already said I will import my libraries and packages, but for this particular lab, I'll be making use of an algorithm or a model called CatBoost. So the very first thing I'll do is I'll have to install CatBoost on my Google Colab machine. Yeah, so for you guys using R, you might also want to do that too. So I'm making use of logistic regression and CatBoost. Yeah, for this classification task. So now to install CatBoost, it's quite simple. I'll say pip install CatBoost on my Colab machine. Okay, so as you can see here, let me highlight it. So CatBoost is installed successfully. So the next thing I need to do is I'm going to set, first of all, I'll import those libraries I need. So for starters, you import NumPy as NP, you import pandas as PD, you import Seaborn as SNS. So you import matplotlib. As if you notice, as I'm typing it, Google Colab is also suggesting it based on inference from what so many people have done in the past. Yeah. Okay. So okay, I would import some other libraries to like scipy.stats as stats. Yeah, I'm recording. Don't worry, I'm recording. So now I'm going to import MSNO missing none as MSNO. So some of all these libraries I might not be able to explain what they all mean, but you can do your work yourself. Yeah, find out. Then, so those things I'll be using to build my model. So I'm going to import from sklearn dot linear model. I'm going to be importing logistic regression. Okay, so from scikit-learn, I'm also going to, and from scikit-learn.preprocessing, I'm also going to be importing my standard scalar. So basically, what my standard scalar is for is, I'm going to use it to normalize the data set, to set it in such a way that it has a standard deviation of 0. Yeah, not really like the mean is 0, it is balanced, like I'm putting it within a range. That's what I'm just trying to do. Then I'm also going to import my train test split. So I'll use my train test split to split my data into training set, test set. That's my holdout set for me to validate what I'm trying, the model I'm building. So to do that, okay, from sklearn, model selection, import train test split. So as you're typing it, it should give you, yeah, it should recommend what you're trying to type, like it should, yeah. Okay, then the next thing I'll also import is I'm going to import my pipeline module from scikit-learn, that's sklearn.pipeline. So I'm going to import the pipeline module. And the next thing is, yeah, I'll be needing metrics and maybe feature permutation importance. So, okay, from sklearn.inspection, import permutation importance. And my metrics, yeah, from sklearn metrics. So what are the metrics we use in classification? You have a lot of metrics ranging from ROC curve that tells you your AUC score, you have F1 score, you have recall, you have precision, yeah, you have your classification report that tells you your true positive, true negative, false positive, false negative, and all those things. Okay, so I'm just going to import just a few. So I'm going to import plot confusion metrics. Yes. Now import plot ROC score curve. Okay. Plot ROC curve. I would also import ROC AUC score. Okay. So what else? Yeah, I think the last one I will import will be my classification report. So I guess we are good to go then. Okay, now so we have an error. Okay, yeah. Okay. So there's an error. Can someone tell me what the error is? Okay. Yeah, so I already know what the error is. It has highlighted it. Well, Colab is now friendly now. This one should be missing none, and I wrote missing. So it should run fine now. Yeah. Okay. So now, the next thing I want to do is, if I run this notebook 10 times or 20 times, I want to be able to produce the same result again and again. So how would I do that? So that means all those all those algorithms and everything that requires a random state, I'm going to give it something permanent called a seed. So with my seed, I'm able to produce the same result again and again. Yeah, so how do I do that? So let's say, okay, I'm importing random. So I'm saying equals to, so someone should give us a 4-digit number or something. Okay, someone is giving us, okay, 1759. Okay. Someone said something. Random.seed So I want it to produce the same result over and over again. Then okay, I'll do mp.random, yeah, .seed also. These things I'm just doing, and they are just like, I haven't started the main work yet. I'm just trying to prepare all those tools I'll be needing to build my model and everything. Okay. So this is good. So I guess we've installed Cat Boost, we've imported logistic regression and other tools we'll be needing. We've already set our seed to 1759. Okay. So now the next thing I want to do is I would need to import this data set and also read the data set. So like I said, there are so many ways you can bring your data into Colab. You can download it using Google APIs. That's if you don't have a lot of data and you want to minimize your data consumption, you can download it using Google APIs yourself. So there's a way of doing that. You have to use you have to get the link, then call a Python module to download the data set for you directly. Or you can download the data once and for all to your Google Drive, then mount your Google Drive on Google Colab. So for me, what I'll be doing in this class is I will be so I've downloaded this data set and I've uploaded it to my Google Drive. So I'll be telling Google Colab the location of where these different CSV files are located in my Google Drive. So before I do that, what I'll need to do is this. So I'll need to set the path. That's like I'm setting the working directory of where this data set is, just like how you've done previously in your Linux environment. So this is my drive. I'm sorry if my drive is bulky. There are so many files there. So I'll need to get the exact folder. So this is the folder here. So I'll just right click on it and go to copy paths. So I'm going to put it in a string, then save it as paths. This will do. Okay. So now it is time for me to read my data set. So like I said, I love documenting my code. Like I love commenting on my code a lot. That way it is easier for people to read. Okay. So the very first data set I want to read is the train data set. So I'll be using pandas to read that. The code remains the same. So it will be pd.read csv. Yeah. So because I don't want to type it, I don't type the long file. So what I'll just do is I already saved my path. So I can say path. Yeah, I'll say path plus. Okay. I'm going to in this particular part, there is a folder called train.csv. Okay, so I love documenting my code. Let me put that this is the train set. Okay, as you can see, that's the head of our data set. So I'll do the same thing for the test file. You can stop me at any point if I'm doing something you don't understand. Yeah. And as you know, in any machine learning competition, you always have a training set and a test set. And sometimes for some funny machine learning competitions, you have to form your test set from the training set. So they'll tell you how to do it, basically. Yeah. Okay, so I believe I should have a file called test.csv in that part. So basically, how do I know? I know I was expecting someone to ask me a question that how do I know the likes of logistic regression, cat boost classifier would work best on this data set? So now there is a particular module that in Python or a particular Python package that so basically what it does is put data set from any competition into it, and I'll tell it to compare all models for a classification task or a regression task, and it returns the best. It returns all of any classification model you can think of, any classification algorithm you can think of. It returns a table ranking all of those algorithms. So what do I mean? For this DSN hackathon now, I've carried the dataset and I passed it into that Python package now. So at the top of the ranking, which those guys that were coming to the office, I showed them how I did that. At the top of the ranking, Catboost classifier was first, followed by LGBM, that's light gradient boosting method. Yeah. Then followed by SG boost, then followed by random forest and the likes like that. So the likes of your decision trees, SVM, KNN, they were at the bottom. Then you also have the likes of your extra trees classifier also performing very well, and your logistic regression also performing very well. Yeah. It's a trump card. I'm not meant to share a trump card that will make me win a competition with you guys for the person asking me for the name of the module or a package. Yeah, you can find out. You can go and do your research. I'm sorry, I'm not going to tell you guys the name. Yeah. We might meet at an hackathon maybe sometime in future, and that might just be the extra thing I'm going to use to win. My apologies. Yeah. Okay. Yeah, so the next thing now is to read our sample submission file also. Okay. So for the sample submission file, so I'll say my sub file is equal to pd.read.csv. So part plus. There should be a file called sample submission. CSV in that part. So I can see my sub file .z, check the head of that data set. Okay. So far is not defined. Oh, I didn't put my /. Oh, so far is not defined. So that means I'm missing this S should be capital S. Wow. Instead of equals to, I kept a minus. Okay. Yeah. So this is it. So this is the way they expect us to submit our predictions. So basically for this competition, we are not submitting zeros or ones. What we are submitting are the probabilities. So you need to go to the competition page to read that and get all of that information. Basically, if you submit 0 or 1, nothing is wrong, but you will be getting a very high score. Like now, if you submit for logistics, I can remember submitting some set of predictions that were in zeros and 1, and I had an AUC of 0.7. But by the time I converted it to the probabilities itself, it went up and I had an AUC of 0.8. Okay. So now that we have our data, the next thing you are meant to do in any proper machine learning project, after you've imported your data, you've imported all the resources you need, next thing you're meant to do is you're meant to perform your EDA. That's your exploratory data analysis. So your EDA comprises of you getting accustomed to the data, you understanding, okay, oh, how does this data look like? You understanding the correlation of the different features. When I mean features, I mean independent variables, if I'm to be technical. Yeah, so your independent variables include from your x1 to x50 or x anything. And your dependent variable is your y, which is your target class, whatever you're trying to predict. So now, like I said, I love documenting my code. So I can just call this place EDA. Yeah. So basically for me, the very first EDA, the very first basic EDA I love doing. So I'm not going to be doing so much EDA like that. But the very first one I love doing is I've also train.describe. So I want to have a feel of this data set. So meaning it gives me the summary. So in your R programming, something related to your train.describe will be summary. Then in brackets, you put your train data set. Okay, so what does it do? It tells you the count of every column, every numerical column in that data set. And then it also gives you details about the mean, standard deviation, the minimum value in that column. It gives you also the distribution history in terms of percentile. So from what you can see here, so let me take the first column now, for instance. Okay. For the first column, you can see here for form field 1. So it's telling you that we have a total of 53,471 entries. Okay. So first of all, I will need to know what's the shape of this data set that I imported. So let's say train.shape. So the shape is, okay, so I'm expected to see 56,000 rows and 52 columns. So it means for this particular feature called form field 1, there will definitely be some missing rows because it is not up to 56,000. Yeah. And the minimum entry in this particular column or feature is the mean of all the entries in this particular column is 3,491. Then the minimum you can see here, meaning the lowest entry in terms of value, is 2,990. Then it is also telling you that about 25% of the whole data set falls below 3,358 in terms of entry. Then it tells you about 50% falls below 3,484. About 75% falls below 3,620. Then the maximum entry or the maximum value you can see in this column is 3,900. So basically, if you have time, you can go through each and every column or feature in that data set. But from experience, basically, I can just glance through and look, okay, and just know what to do. So now let me show you how to spot anomaly in this kind of summary now. So now you can see for this column called form field 16, it's telling me that the maximum value I can see here is 0. For form field 17, the maximum value I can see here is 0. I'm sorry, I said maximum value. My apologies. Okay, so for form field 16, it's telling me that the maximum value I can see here is 11. The maximum value I can see for form field 17 is 21. And from the same summary of the data set also, it's telling me that 75% of this data set falls between, is either less than 0 or equals to 0. So it means, yes, so these entries that have 11, 21, and 21, they are most likely to be outliers. So that's one way of picking out or eking out outliers. So I'm going to iterate over it again. So now look at this column called form field 16. The very last value you can see there is the maximum value in that column. Then after that, if you check the value above it, you will see 0, and that 0 stands for the 75% percentile distribution of that column. So what that is telling you is that more than about 3/4 of the whole data set is equals to 0 or less than 0. So what is also telling you is that the minimum value in that data set, in that column, is also 0. So it means that if more than 75% is equals to 0 or less than 0, you now having an entry of 11 or an entry of 21, it means that 11 and 21 are outliers for form field 16 and form field 17. So that means columns like this, you have to check them out. Oh, do I need to remove outliers from these columns? Do I need to perform any feature engineering trick, like maybe I should create clusters or I should bin them? So what I mean by create clusters or bin them is like that form field 16, I can categorize it. I can have class 1, class 2, class 3. So that way your model will be able to learn better. So one thing about machine learning and model building is that the more your model is, your whatsoever machine learning algorithm is able to understand your data, the better its predicting power. Yeah. So, and again, one thing you also need to know is that some machine learning algorithms are susceptible to outliers, meaning any little outlier like this, they will start messing up and start misbehaving anyhow. An example of such is you have the likes of your SVM, you have your linear regression, and the others too, and logistic regression too. So what it means is that when you're already having outliers, you can normalize your data set or scale your data set, to set everything within a range, so that your linear algorithms will perform well when trying to predict with such entries. Okay, so that's for that. That's one of the things I can do there. Wow. Okay, so that's one of the things I can do there. Then another thing I can also do when it comes to EDA is I can check for unique values. So how do I check for unique values? So I can pick the whole data set and know the number of unique values I have in each column. So that way you can know how, you can also have a feel of how that data is being distributed. So to check for unique values, I'll say train.nUnique. Okay. Yeah, so the good thing about Colab is if you don't remember the function, just start typing, it will suggest something for you. Okay, so there's what we call sort values in Python. So it will sort all the values from lowest to the highest in there. So automatically you can see the very first column you have here is the target column, which is your default status. We are trying to predict if a customer will default or not. So if a customer is going to default or not, it means we have just two classes, yes or no. And as you can see, it's telling you the number of unique values you can find in that column is 2. So you can also see another column called form field 47. The number of unique values in that column is also 2. So what that is telling you is that this form field 47 is likely to be a categorical feature. So that means you will have to handle categorical variables. So you can either replace or get dummy variables. Yeah, you can manipulate it anyhow. There are so many ways of doing that. Okay, the categorical features, is it ordinal? So what do I mean by ordinal? I mean, is it low, medium, or high? So if it is an ordinal categorical variable, some machine learning algorithm will require you that you need to state that yes, so this categorical variable, it is an ordinal, it has an ordinal characteristic. So that way they'll be able to perform better. That means low will have a lesser value than medium. Medium will have a lesser value than high. So that means if low is 1, medium will be 2, and high will be 3. So for these ones now that have 6 unique values, now you can create quadrants for them, or bin them, or bucketize them anyhow you want to. For these ones having 11 unique values also. So this is just one way of thinking of how can you perform feature engineering on your data set. So it is from your EDA that you would know that, okay, what do I want to do? What do I want to do? But for the purpose of this class, I'm not going to perform any major feature engineering. I'm not going to create more features. I'm not going to do any major thing. The only thing I want to do in this class is pack the whole data set and push it into logistic regression. Let us see the performance on the leaderboard. Then pack the whole data set again and push it into CAT boost algorithm and see the performance on the leaderboard. Then it is now up to you to either write your machine learning program in R or Python, perform different features engineering and the rest, and increase on the leaderboard like that. Or you can even go as far as stacking up of models, that is using assembly techniques and the rest like that. Okay, I'm sorry if I'm passing out too much information at once, but that's why we're recording this class. You can always go back to the recording. So now another EDA I would love to do is I want to know the number of missing values in each column. Okay, so now the same thing I did for unique, for the unique values, I also do it for the missing values. Okay, so to check the sum of missing values, okay, let me comment this for anybody who will be looking for it. Checking the count of missing values. Okay, train dot, there's what we call is null function in Python. So I'm going to sum it up. Yeah, after summing it up with the sum function, I'm going to sort it out. So sort values. Okay, so when I run that, you can see automatically it will rank it from bottom to top. So in the applicant ID, which is your unique primary key, there is no missing value. So meaning this data is clean to an extent. You shouldn't be having any missing value for your primary key. For your form field 47, there's no missing value. Form field 14, there's no missing value. But if you come down to the last one, for form field 40, you see that you have about 43,729 missing values. So meaning you start thinking, okay, for that kind of column now, do I need it when building my model? Do I want to drop it or not? Okay, how do I fill up missing values in that kind of column? Or does missing values in this particular column, do they depend on another feature or another column in the data set? So those are the kind of questions you will ask yourself too. Or what do we do? This form field 40, do I make it a categorical feature? Do I create another column in place of it and say, okay, if you have a value, it is 1. If you don't have a value, let's give it 0 in that new column I'm creating. So those are some tricks to feature engineering that you can do. Then, yeah, same thing goes for others too. Then you ask yourself too, this form field 40 now, you can go back to your train.describe and go and check what kind of values do you have inside. Okay, how do I fill up the missing values if I want to fill it up? So for form field 40, it's telling us that the maximum value there is 645, and about 75% of the data sets is either equals to 167 or less than 167. Okay, so you start asking yourself question, okay, since it has a lot of missing values, do I fill it up with a value like 1000? I know that, okay, yes, I'm filling it up with 1000, meaning it is going to be greater than the maximum value in that particular column. So feature engineering is dynamic. There's no specific way to doing it. It is from gaining insight into the data set. Like, it is from having that sort of empathy, like you're trying to solve a problem with the data set, that you get to have different inspiration of, okay, what should I do? What should I not do? Yeah. Okay, so that's that for missing values. Yeah, that's that for missing values. So there are also different ways also. You can also check for yeah, my apologies. When you check for missing values in your train set, you also need to check for missing values in your test set. So to know that, okay, is there any correlation between your train set and your test set in the way they have missing values? Okay, so we run it for the test set. So for the test set also, for form field 40, we have a lot of missing values. It has the highest number of missing values. So our test set has a shape of 24,000 rows. And for form field 40, we have missing values of 18,828. Wow. Okay. So that's that for missing values. To also make it sweet, you can also plot out your missing values. Like you can also give it a visual representation. I'm not going to be showing us how to do data visualization with Python, but I'll just drop it there basically for anybody that wants to make use of the code later. Yeah, I'm not going to be explaining that. Okay, so I'm going to plot out a visual representation of missing values. So as you can see, form field 40 have about 78% missing values from this data you can see here. So we are going to do the same thing for the test set also. Also has 78%. Yeah, about 78% of the total shape is missing. Yeah, 78% missing values of the whole data set. Okay, so now after doing all of your EDA, so in your normal machine learning project now, after your EDA will give you insight of the kind of feature engineering you will do. So after doing your feature engineering and everything, the next thing you need to do as part of your EDA is you need to check the distribution of your targets. Yeah, so what do I mean by that? So now we're trying to predict if a customer will default or not. So now I need to know, do we have plenty defaulters in the data set than non-defaulters? Okay, so one way to do it is I can call the column. Okay, so I need to get the target column. Okay, so the target column is default status. Don't worry, I'll share this notebook with you guys. So I'm going to check the number of unique values. Oh, I'm going to try to sort it out. Just sort values. Oh, that won't work. That won't work. Oh, not an unique. My unique will work. Okay, it's not giving. I guess I'll just plot it out. So you see what I'm talking now. Okay, so from what you can see, it means for the no, the whole size of the data set, about 75% of it is no, and about 25% of it is yes. So this is an imbalanced classification task. We have more zeros than 1. So you start asking yourself questions like, okay, how do I want to fix this imbalanced data set now? So do I want to use different techniques to make it balanced? So you have techniques like your SMOT, SMOT. You have techniques like your stratified k-fold cross-validation. Then you also have, you have techniques like your SMOT, SMOT. You have techniques like your stratified k-fold cross-validation. Then you also have techniques like, there's a function, there's an argument available in your train test split, function in Python. So it allows you to stratify the target class. We'll do that here. So don't worry about that. I'll show you guys how to do it. Okay. So now, the next thing now, guys, is to label our target class. If you check in our target class, what we have is no and yes. So I want to replace no with 0, then replace yes with 1. So how do I do that? So I'll just type it in this. I'll call the name of the column default status. Then the next thing I want to do is I want to replace. So there are so many ways. Some people can replace using label encoder or one-hot encoder. Some people can get dummy variables. So there are so many ways to doing this. There's no specific way at all. So now I'll just be using the normal replace. In my replace, I'm going to create a dictionary of key value pairs. So the very first thing I'm putting is my no. So I'm replacing no with 0. Okay, I'm replacing no with 0. I'm replacing yes. Okay, I need to type it the same way too. Okay, I'm replacing yes with 1. Okay, so after doing that, I'm going to make sure it is done permanently. So I'll say in place is equals to true. For those guys who code in Python, you know what I mean. So I'll run this, and that's that. So by the time I check the unique values in that column, you see that it is no longer no and yes. It is now 1 and 0. As you can see, we now have 0 and 1. So now, guys, we are getting closer to the interesting part. So we'll soon be building our model, performing the little feature engineering or filling up missing values. So one thing I'm going to do now is I'm going to write a function. I'm going to write a function to check my model performance. So to write that function to check my model performance, what's our major metric now that we're looking at? So the major metric we are looking at is our AUC. So now I'm going to say def model AUC. So what am I passing into it? I'm going to be passing my model into it. So it's not compulsory with some of these things I'm doing, writing a function to check the performance of my model. So basically for me, I just enjoy doing things like this, because it gives you room to be flexible and do so many things. Okay, now, so I want to know the AUC of my training. So I can say train AUC is equals to, then I'll call I already imported an ROC metric from scikit-learn. So what I'll just do is I'll call my ROC AUC score, then I'll pass in the necessary parameters into it. So I have my Y train, then I'm going to call the function of my model dot predict probability. Okay. So which probability am I predicting? I'm predicting the probability of my X train. I'm sorry if this is too technical, but you would, yeah, you will get it with time. Okay, so I'm predicting for all rows. Then my probability would be in the second row because it will return the label and return the probability, which is the score. Okay, so I'll do that too for my hold out set, which is my validation set. So I'll say my validation AUC is equals to ROC AUC. Okay, yes, it has suggested that. And same thing, predicting against my Y val. Then I would say the model should predict the probability of my X val. Okay. X val. Then what I want to take are just the probabilities. Okay, so I'll do this. I'll take wow. I'm sorry if you don't some of the technical things, but you will go through the code later. Yeah. The major thing I'm just trying to show you guys today is I want to show you how you go from taking the data sets from the competition page, loading it into your programming environment, making predictions, submitting, and seeing how you can improve on the leaderboard. So I don't know, anyone who wants us to use his account should send me his details privately. Yeah, let's send it to me on WhatsApp, your Zindi login details privately, so we'll use it to experiment. Okay, next thing I want to do now is I'm going to print out the score. So let's say print. Yeah, that's all. I'm good with that. So I'm also going to write a function to plot out some figures and the rest. I'm not going to explain that in detail. Don't worry, you people will soon get to the place where we are building models. Okay, so you should be able to understand this part. Now we are filling up missing value in the data set with 0. Okay, I'm just document it. Okay, so how do we fill up missing values with 0? So you just call your data set and say .fill NA. Then you call the name of the value you want to fill it up with. Then when you say in place equals true, what that means is that you want it to be permanent. Okay, so we are done filling up missing values with 0. So we are not done with EDA. If you look at it, we can still do another EDA by checking features correlation, checking how all the features correlate to one another. Yeah. Okay, so I'm just going to pick. Hello?
Yes, sorry to cut you short. So I would like to ask, why are we filling up missing values with 0? Is that
Like I told you,
I
this is
don't know.
just an experiment. Do you
Okay.
get? I'm not doing any deep feature engineering, checking what to fill up missing values with on each column. So basically, all I just want to do in this class is carry the data, fill up missing values with 0, pass it into my algorithm, submit on the leaderboard, then check what the score is, go back to my
Okay.
programming environment, carry the data, pass it into a better performing algorithm, and see the score. Yeah.
So
So I'm
that,
not
that
doing. You
okay.
said?
So that means why I said that means why treating missing values, right? There is really
Yeah.
no conventional way to do that. We just
Exactly.
have
So now
okay,
let me tell you
okay.
something about missing values. Let me just give you some tips on filling up missing values. So basically, me in a standard hackathon, wow, I don't know why I'm sharing this secret. So I love filling up missing values after I've gone through an histogram distribution of every column. That way, I'll be able to identify outliers and I'll be able to know how each value, how many times they appear in that particular column before I decide on which value to replace with missing values. So now you can have a column whereby all the values are between 0, 1, 2, 3, and 4. If I want to fill up missing value for that column now, I can just pick up a -20 and use it to fill up that column. Automatically, my algorithm or whatever algorithm I want to use will know that yes, so those -20 they are for something. Yes, they are for particular cases whereby we don't have entry for that record. And also some very basic simple ways you can fill up missing values. You have the mean, filling up with the mean of that column, filling up with the median of that column. Yeah, so there are so many ways. Then for some, if you are going to be using some very strong or sensitive algorithm, you will see some people filling up missing values with -999. That's if you are using an algorithm like SGBoost or LGPM. So those algorithms we easily know that yes, so you are actually trying to tweak or manipulate something at this particular entry or record. I hope I've been able to answer your
Okay.
question. There's no conventional way.
Yes, yes. So one more thing. So do we? Okay, I think. But let me just ask. We don't treat zeros as missing values. Just leave it the way it is.
So zeros are not missing values in any data set except stated. So basically, what you even treat as missing values in some data set, like now, for people in the oil and gas industry now, if you are working maybe seismic data now, or petrochemical, or data coming from oil wells and the rest, they will tell you any entry you see that has -999 is a missing value. So that means you have to go back to the data set and replace any entry where you see -999 as either zero or as a missing value. Yeah. So I'm talking based on experience in a petrochemical competition also. Yeah. So they will tell you whatsoever you should take as an invalid entry. They will tell you in that competition. I hope I'm able to answer your
Okay, sir.
question, sir.
Yeah, very well. Thank you very much.
Okay. So now, like I said, we never finish EDA. So EDA is continuous. You see some people going as far as reading research books just to gain insight into the domain of that particular competition to know how to perform EDA. Like now, machine learning competitions are sweet in such a way that this particular machine learning competition now, it can be in the insurance or fintech industry. You see some people going to go and read newspapers, journals, research papers on insurance and rest just to learn all those things and everything and know how to perform EDA. That's why it is always good that you gain domain knowledge a little or you have a domain expert with you in any machine learning project. That way they'll be able to relate with you better and explain some things to you. So now to continue with EDA, I'll check how all the features correlate to our target class. Okay, I'm going to sort it out. The last one will be the one that is highly correlated. Okay, so from what you can see that form field. Okay, so let me tell you something about correlation. You know, normally for correlation, negative correlation and positive correlation, they are all correlations irrespective of the sign. So the sign will only tell you the direction in which it is correlated. It's like saying something is directly proportional and another thing is inversely proportional. So meaning if I have a feature now that is inversely correlated to my target class as let's say -0.39, then I also have another feature that is correlated directly as 0.25. The one with the highest correlation is the one with the -0.39. Why? Because it has a larger distance on the negative side. So I want you to see it that way. It's just like as if you are talking of margins in your SVM. Okay, don't let me go there. So just see it that way, that it is the value itself, the distance itself. So meaning in terms of correlation, anyone that has 0 and anyone that has 1. So 1 means perfectly correlated, whether it is minus or positive, perfectly correlated. Then 0 means no correlation at all. Then one thing we need to, so basically I know you would have learned 1 or 2 things about correlation. So in any machine learning project or competition or anything, so one thing we do is we try to set different thresholds for correlation, meaning if I see a particular feature is extremely correlated to the target class, I will make use of that feature. But there's something we call multicollinearity. I don't know if they've taught you guys about that in your DASCA. So what multicollinearity means is that if you have 2 independent variables, meaning you have 2 features that you are going to use to predict your target class that are highly correlated to one another. So meaning in this data set now, if I have a feature like form field 21, form field 11, and they are highly correlated to one another. So let's say form field 21 has a correlation of 0.85 to form field 11. It means I must drop one of those features. Why? Because my model would not perform better. It will be very difficult for my algorithm to have a very good predictive power over features that have high correlation. I don't know if okay. Let me plot its map of correlation for you guys to see that. Okay, yeah. So I'm going to plot its map for correlation. Yeah, that way. The correlation, yeah, I'm checking the correlation for the training data. Yes. Okay, so this is it now. Or you can even just call your data set and say trend.core. Give it to you in a matrix form. Okay, so now if you have one or more features that are highly correlated to each other, you need to drop one so that your model wouldn't get confused. That way your model will perform better. But if you leave it, your model will most likely not be performing better. And another way you can use to select important features is using correlation. So from this now, you can know that, oh, if you remove some features, actually, they will not actually affect the predictive power of your model. And if you remove some features, it will help your model to perform better. So it also gives you an insight to how we can create more features. So meaning, are you going to create more polynomial features by taking the product of some of your features and creating new columns for them, or taking the ratio of some of your features, or taking the square of some of your features and adding them up? Like, you can manipulate anything. You can even aggregate some of your features. You can find the sum and average of some and just, yeah. So there's no specific way. It's a no man's land. Like, it might just be one simple inspiration or thought that will make you win the competition. Basically, like what professionals will tell you, na feature engineering they win competition. No be algorithm, no be, you can see some people are very crazy. Like, they'll use something as simple as KNN to win a major competition. Why? Because their feature engineering is mad, and their training process, the parameters that they set and everything is crazy. Yeah. So basically, there's no specific way. And another thing I want you guys to know is that, okay, when I get down, I'll talk about it. Yeah, so that's that for correlation. I guess we can go to creating our model now. Yeah, I know a lot of people have been waiting for that. Okay, so let me check. for someone that sent me his or her detail. Yeah, so I'll be submitting for the person on Zindi. Okay. Let's create a logistic regression model now. So the very first thing, we need to take all those applicant ID from the test set. Yeah, so I need to save it in a certain variable. Okay, so I'll do that. Test is equal to test dot okay. Yeah, that's suggested now. Okay. The next thing now is I need to pick up my features. You can see it's not so much of a stress if you know what you want to do. Within 5 to 10 minutes, you build your model and you're submitting. Okay. So the next thing I need to do is I need to select those features I want to use to train the model. Okay. So I'm not training with the applicant ID. Anything that any column that has high cardinality, it is not good for your model. So what do I mean by high card? I'm sorry if I'm using too much of a technical term here. So high cardinality means that it has a lot of unique values. So like your applicant ID column now, it is very distinct and has a lot of unique values. So in your table, it might be saved as an integer or as a float or something. But because the cardinality is very high, meaning because it is distinctively unique, it is not good for your model. So we're not going to be making use of it. So I'm going to drop a column like that. So I'll be dropping the applicant ID for my train. Yeah, for my train. So applicant ID. I need to drop or select the columns. I mean, dot columns, not applicant ID. Then also my target class, I don't need it to be in as part of the features I'll be using to train the as part of my X. What I mean by my X, I don't need it to be there. I would separate that one separately. Okay, so I would say my X is equals to, because I have, okay, so this is what I'm trying to achieve here now. I have a categorical column in my data set, and that categorical column is form field 47. Because I don't go through the stress of making it categorical, I will just make pandas create automatic columns for all the classes in that particular feature. So I'll just say pd.getDummies. It has suggested that. So I would say train. Then I'll index all the features. I'll pass in the list of features I'm using to train. Yeah. Then I need to set my target variable also, which is my y is equals to train dot default status. Okay, yes, suggested it. Then yeah, my test also. So whatever you do to your train, you do to your test, except if you concatenate it, pass it through a pipeline. There are so many ways to do this thing. Like there is no generic way. You can go on Kaggle now and you see someone else. You see someone else's notebook and you'll be like, what did this guy do here? If you take your time to read it, you would get what they're doing. Okay, so that is fine. We are making 4 submissions today. Yeah, so I haven't seen anybody's detail or anything. Nobody has sent me anything on WhatsApp. I'm yet to see someone sending me their Zindi login and Zindi username and password. The very first one I see is the one I'm using. Yeah, I'm pushing for submissions for this person. Okay. So when I run that, okay, I've run that. The next thing I need to do now
Sorry, Temilola.
Okay.
Yes, you were saying something about password just now, please.
I said what I'm doing in today's class, I'm submitting it on Zindi to someone. Yes, so someone should send me their Zindi login details.
Okay, can I drop it inside the chat box?
No, I've seen. Okay, the very first one I entered was from Richard. Thank you. Don't worry, don't send any more. Richard has sent me his own. Okay, so I'll be making 4 submissions for Richard today. With whatever we do in class. So you guys can also replicate it, but use a different random seed and try to make the code unique or your own. Okay. So now the next thing we need to do is call our train test split. Okay. So I'm going to call my X train. Yeah, my X
Hello, sir.
val. Yeah, Y train.
Yeah, sorry. Please let me drag you back a little. Please, can you reiterate what you said about the categorical variables that we have on? I think that should be from field. I can't remember the form, but I know we have
Okay, now.
categorical variables. And
So
you're
there
saying
is a
something about
categorical
it.
variable called form field 47. It has just 2 classes. I don't want to undo it specially, so I just want pandas to do it for me automatically. That is why I passed it into pd.getDummies. So what that does is it goes into my data. I pass my data set into it. It goes into my data set. Then look for any column that has string or character features that has just 2 or 3 or 4 classes. Then create each column per class. So look at what I said here now. So if I say x.columns, if you notice, form field 47 has changed to form field 47 charge and form field 47 lending. So we now have 2 new columns, and it has gotten rid of form field 47 as a whole. Do you get what I'm saying? Then if you check the entry in those columns, wherever it is charged, if it is form field 47 charge, wherever it is charged, it will give it 1. Wherever it is lending, it will give it 0, like that. I don't know if you get that.
Yeah, I got that. Thank you.
Okay.
But
So now I'm trying to divide my data set. Okay, go on.
okay,
Are you
I
saying
think
something?
it's just yes, I was about saying something, but I think it's about the same method, the same result, anyways. So you
Yeah,
can go
it's
on,
the
sir.
same result, but faster way. Okay. So now I'm calling my train test split. I want to split my data into train sets and test sets. Okay. So I'll pass my X and Y. Then I need to specify my training fraction. But first of all, I need to pass in my random state. My random state is equals to the seed because I need to be able to produce this result again and again. So I need to, okay, my test size. So personally for me, since this is just like a train test split, I'll use 80/20. The data set is quite large. So I'll just put in 0.2 for text size. Then, like I said, since it is an imbalanced classification task, one thing you can do is stratify your target class, and your train test split gives you that option. So you just need to type in stratify and you specify which of the variables you want to stratify. That's my Y. So normally not so many people know about this particular trick. Okay, so everything is good. I'll run it. Okay, then I can now check the shape of the data set. Okay, so I'll check the shape of my X train and X file. So I'm training with 44,000 samples, then I'm validating with 11,200 samples. So now, watch what I'm about to do now. What I'm about to do now is quite simple. I am about to create a small pipeline. So when I say pipeline, it's not a big deal like that. So I want to scale my data set. So I'm going to initialize, I'm going to instantiate my standard scalar. So after instantiating my standard scalar, I'm not going to pass it into the data set immediately. So I want my pipeline to do that for me automatically. Then the next thing is I'm going to instantiate my logistic regression also. So I can call it logreg is equals to logistic regression. I'm not putting in any extra thing like maybe parameters, hyperparameters like my learning rate and the rest. The only thing I'm putting is my random state, which is my seed, because I need to be able to reproduce the result, which is my seed. I'll instantiate that also and run it, and everything is fine. Then the next thing is, this is where I'm creating my pipeline now. So let's say my pipeline is, let's call it, train PL. MPL. So once I scale the data, I want to train on it. So how do I do that? I'll call my pipeline and just like your key value pairs. So just like your key value pairs, the standard scalar and the logistic regression that I just instantiated, that's what I'll pass into it. Okay. So now for my standard scalar, I have scalar, I do for logistic regression pipeline also. So okay, that will be my logreg. Also be my logreg. Okay, so I'm going to run that. I'm getting to the part of training now. So once I run that, next thing I do is I just need to call my pipeline into my training set. So I'll just say my train pipeline. I said this method I'm using, I hope some of you will be able to get it, but there are so many ways to it. So I'll say my train pipeline dot fit. So X train and my Y train. X train and Y train. So now it will run the training for me. So it's already training on data sets. It is done very fast. Very, very fast. Okay. So the next thing is so someone says the pipeline is not clear. So basically what I'm doing is I want to scale my data set and also train on that data set. So what I mean by scale my data set is if I use standard scalar on the data set, it will scale it, then convert it to an array format. So as it is coming out like that, I'm pushing it inside my logistic regression algorithm. That is just all what I am doing. There's no big deal about it. So I'm able to do that because it is a pipeline. As it is coming out from one function, it is going into another function. So what we mean by pipeline is it is coming out from somewhere, then going into another place. That's just all. So it is coming out from my standard scalar and going into my logistic regression. So that's just all. I hope it's clearer now because someone told me it's not clear. Okay, so the next thing is I already wrote a function to check my model performance. So I'll also check it on my train set and my validation set. Okay, so there is an error. So this should be train PL. So from what you can see here, it is telling me that for training, I have an AUC of 0.829, and for validation, I have an AUC of 0.81. Can we all see it? Okay. So the next thing now is I would have the next thing now is I wrote a function to plot out the result. So I'll just say I call the function called plot figure. Yeah, go on.
Yeah, please. The validation, what's that? What does it signify?
So the validation that I did here is like my testing my testing data, my holdout data. So the validation AUC here is, or the test result here is 0.8196. You get, I'm testing on data that the model has not seen, and it's saying 0.8196. Do you get? I used 44,000 to train the model, then 11,000 to test the model. Then you can interpret all of this yourself, the confusion metrics and all. You can do that yourself. So the next thing that is important to me now, okay, I can print out classification report for you guys, but what's important to me now is to make predictions. Okay, so I'll just print out classification report for you to see. Yeah, so this is run because I'm using train PL. Okay, so that's the classification report. I'm not going to explain that. Some little reading can do that for you. So now, since I've built my model, I'm going to test on the test data itself. Yeah, so if you check it, I split my training data set into 44 and 11,000. So ideally, since I want to predict on the test data itself, it will make much more sense for me to go and train with everything, then now predict. But let's just see how it performs if we predict with just the 44,000 model that we built. Okay. So permit me. So basically, we are submitting prediction probabilities, and for you to get prediction probabilities means what's the probability of a customer defaulting and what is the probability of a customer not defaulting. So we are just submitting the probabilities. In your normal classification task, you see zeros and one. So what it does is that it sets a threshold of 0.5. If you are below 0.5, you're automatically a 0. If you are above 0.5, you're automatically a 1. So basically, how is that useful to you? For some competitions whereby you don't have enough data on one, what some crooks like me do is that we reduce our threshold to 0.3. So what that means is that if you are above 0.3, you are a 1. If you are below 0.3, you are a 0. That's because for some competitions, it is very difficult for you to predict a 1. So we want to predict 1 by all means. So one thing we'll do is we'll get the prediction probabilities, then now set up a rounding up threshold. So I've seen there are competition whereby out of like 10,000 predictions, you could only predict 1 3 times. So you see some crazy guys like us who just, our probability threshold will be 0.05. So if you can be at least 0.05, that means you are a 1. It can get as bad as that, because imagine predicting if an airplane will crash or not, How many times do you hear that an airplane crash? It's just like maybe once in a year or twice. It is very, very rare. So the probability is always very slim. And if you are participating in any machine learning competition like that, you just find out that you are predicting zeros. Your accuracy can be 99 or even 98, but yet on the leaderboard, you are chopping beans. You are not doing well. So it happens like that. I just need to throw more light for people that will be asking questions. So now I'm creating my submission file. I've made my predictions. I'm creating my submission file. Yeah, so I'll just go straight to the point. I'm submitting for Richard. So okay. Oh, did I define text ID? Oh. Okay. Oh, this should be test capital ID. Okay, yeah, it's run now. So I'm going to call this, and again, when submitting, you need to set your index to false. So meaning you're just submitting 2 columns. For those of you programming in R, you need to make sure you're only submitting the applicant ID and the default status. So you don't need to submit the index or the row ID that comes with it. Just make sure it is just 2 columns. Okay, so I'll call this Richie logreg 1. Okay, so I've run this now. Okay, so I need to share my entire screen. Okay, so I'm going to download it. So I'm going to open incognito and log in as Richard on Zindi. Okay. Okay, so please give me a minute. I need to log in as Richard. So I need to also stop sharing my screen. Okay. I'm sorry I'm taking so much time. Richard's password is long. Okay, saying wrong username for Richard. Maybe I'll just use the next person. I'm just posting it the way you sent it to me.
Hello, sir. While you try to log in for Richard, I would like to ask a question. So,
Okay.
I want to know what are the scoring? How do they score these submissions? Right, when you make submissions on the platform, how do they score it? Do you?
So basically, they score it the same way you check your AUC score in your the same way you check your OAUC score, they just carry your predictions,
Okay.
then pass it into Richard saying wrong username, I guess.
Richard, go asleep.
Okay, I have ability 01 for here. I think that one is easy.
Emmanuel, why are you fighting this thing with us now?
Why are you sending your
Don't know, Mr. Emmanuel wants to tutor again.
Okay, sir, I want to ask a question. For an imbalanced data set, is it possible to just use, because I remember one doing a logic issue regression before and changing the class, like I used to think hyperparameterization was just what makes
Models
but you
better.
said
What I
EDA.
didn't get you. You said
So
what?
basic question is hyperparameterization that's working on your model and working on EDA. There's one way than the other.
Can you come again? I'm sorry.
Hyperparameterization and EDA
Using
when it comes to getting
hyperparameters and EDA.
yes. There's one way more than the other when it comes to your getting a better accuracy score in your model.
No, basically one does not weigh more than the other. So let me explain it now. EDA would let you know the kind of feature engineering you can do to the data set itself. What hyperparameter does is it lets you specify how your machine learning algorithm should train on the data set. Do you get? It lets you specify things like your learning rates, your number of estimators, your number of leaps and prediction depths. It lets you specify maybe you want early stopping rounds to prevent overfitting, so many things. And each machine learning algorithm have their own hyperparameters that you can set. So one way of getting the best hyperparameters, we call it hyperparameter tuning. So one way of getting the best hyperparameter for a data set, we have so many ways. We have grid search, we have random search, then we have Bayesian optimization. Bayesian optimization technique. So basically, for the likes of machine learning algorithms like your LGPM and the rest, one thing I advise is grid search and random search. But since these things are still limited to the parameters you set in your grid search and random search, where you are thinking something is too much, some crazy guys can be using something that is far beyond what you think is not possible. Why? Because they are using a system that is not limited in memory and computing power. They can run almost anything. It's like choosing the best neural network architecture now, or maybe ANN or RNN architecture. You don't know which one is the best. That's the truth. It is an art. There's no specific. You see someone that will just use 2 layers, and in each of the 2 layers, they might use 3 nodes in the first one and 1 node in the second one, or 2 nodes in the second one. That is all. And it might use early stopping rounds for the number of epochs and everything. So you don't know what is best. It is an art. It is dynamic. What can work today on a particular data set might not work very well on another data set. Like now, you guys said SVM performed well in one of your data sets. In this data set now, if you use SVM, you will most likely not do well. Because when guys are using likes of SG Boost, LGPM, and the rest. So now let's submit for Richard. Can you all see my screen? So I'm making a submission for Richard. Can you see my screen? Okay, so we're going to submit for Richard and see his score. Can you guys see my screen?
Yes, sir.
So we're going to submit for Richard. can see. So Richard, this thing doesn't want to submit. Okay. So this is Richard's first ever submission on Zindi. We hope they're doing well. So let's just wait for it to get its score. So now, marvelous. As you can see, it's rolling now. They are passing Richard's predictions into maybe a function that is already saved into an API to get the AUC score now. But the thing about this competition is that they are testing it on just a certain part of the data set, a small part of the data set. So Richard's first AUC score is 0.827, as we can all see. So now, let's go to the leaderboard and check where Richard is ranked on the leaderboard with that score. Okay, so 0.827. A lot of people have been smart recently. So, okay, wow. 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 Okay, it should be on page 8 is not okay. Wow. Okay, let's go to page 7. Richard should be on. Okay, Richard is on page 7. So Richard is, with that little thing we did, no feature engineering, no major filling up of missing values, no hyperparameter tuning. Out of 851 data sets in this data scientists in this competition, Richard is ranked number 339. So this is Richard being ranked number 339 with just training on 44,000 samples of the data set, not the whole 56,000. So that means if we train on the whole 56,000, it will move up higher. If you use a higher or a better performing algorithm like cat boost, it will move up much more higher. So now let's train a cat boost for Richard. Yeah. After which we will not train on the whole 56,000 data sets and submit. No, he will do that himself. Yeah, so let's just train a cat boost and submit and see where he is. Okay. Okay, so I'm getting the script ready. So we'll just run it straight once and for all, and we don't have to start explaining. It's the same method we use for our logistic regression. We are not specifying any hyperparameter at all. The only thing we are passing in is just random seed. Okay, so give me some time and I would share my screen. Okay. Okay, so I'm about to share my screen now. Basically, what we are doing in this class, it's more or less like a benchmark for those guys that use Python. It's like a baseline for you. Feel free to do any form of feature engineering you want to do, hyperparameter tuning and all like that. Yeah, I guess the work is easier now. Okay, so I'm going to share the screen now. So I believe you can all see my screen now. So to train the cat boost model, so first of all, from cat boost, I will import the cat boost classifier. So after that, I would also pass my cat boost and my standard scalar into a pipeline. Then, as usual, I'll pass in my cat boost into the X train and Y train. Yeah, it's training. So basically, I didn't specify any hyperparameter. So I expect cat boost to do its thing and train for some time. And train like that. Then when it stops, we check the AUC, we plot it, and yeah. Okay, this might take some time. Yeah, it's done then. Okay, so now let's check the AUC for the cat boost. Wow, on the train set, it has an AUC of 0.91, and on the validation set, it has an higher AUC of 0.83. Okay. So I'll plot it, print the classification report. Then I'm going to create the submission file for Richard. Second submission file for Richard. So I'm going to cut Richie first cut it. Okay. Okay, so it is done running. I'm going to create the CSV file, download it, and submit it on Zindi for Richard. Okay, so this is it here. So now I'll stop sharing my screen. Let's go back to Zindi. So we're going back to Zindi. This is Richard's page. Let's submit. Oh, you guys can't see my screen? I'm sorry. Okay. Okay. So I'm about to submit for Richard now. I'm going to select the file. Then let's say Richard first CAPTI experiment. Let's submit this and see the performance on the leaderboard. Then we can now take maybe any question or any additional listen. You guys can then go back, train on the whole 56,000 samples. Don't have any old out sets, meaning don't have any validation sets. Just train on X and Y. Yeah. Then from there, perform feature engineering, fill up missing values in a more reasonable way, then perform hyperparameter tuning, and may the best model win. So from here, Richard has an AUC score of 0.8407, all the way from 0.827. So meaning Richard should be having a very big leap on the leaderboard from 339 to what?
Yeah, maybe what's the code?
Okay, so let's go and check. Okay. Okay. Okay, it's nice. So Richard has moved from number 339 to 247.
Come again, I didn't
Yeah.
hear you.
So if the leaderboard stays like this, Richard will qualify for DSN's bootcamp. Yeah. With just 2 submissions, Richard is in the top 250. without doing feature engineering or hyperparameter tuning.
It has changed.
So it's in number 246, not 247. 246, that is Richard, with just 2 submissions. 246. Yeah. So, any questions? So if I were to be Richard now, I will go and train on all the data sets. Meaning I'll go and train on the whole 56,000 samples. Then
I didn't hear you.
feature engineer. Okay, let me just do that. Let me show you guys how we can still move up by training on all the data sets. So yeah. Okay, so I'll quickly train on all the data sets. So now I'm going to train on all the data sets
Yes,
now.
I'm hearing you. What is the code?
Okay. So I'm currently training on all the data sets. If you have any question, I know. If you have any question, you can ask me. So while the model is training. No, it's not. No, no, no. You can use pipeline for anything. You want to use it for. No, it's not because the data is imbalanced. That's why we are using stratified Y. You can use pipeline for anything. Anything you want to use for. You can have a training pipeline, a testing pipeline, a deployment pipeline, different things. Yeah. So it's just up to you to go and do further research on that. So now after training on all the data sets now, the validation scope for Richard has increased. Yeah. So now I'm going to create another submission for Richard. Using all the data sets. Okay, so I have the CSV file. I hope you guys can still see my previous screen. You can see the leaderboard, right? Okay, so now I'm going to make the final submission for Richard, and if no one has any question by then, I guess we'll call it a day.
Okay, so Statimulola, one question.
Okay.
So
I can't hear you,
for
Marvelous.
instance, can you hear me now?
Yes.
Hello. Okay, so
Yeah, I can
the
hear you now.
categorical variables that we have on field 47. So take for instance, we had now for this particular data set, we had just 2 categorical variables, right? So take for instance, we have like 4 categorical variables. Are we still going to? Is it still going to be the same approach, or there be a different way to approach that?
So basically, like I told you, machine learning is an art. There are so many ways to handle categorical variables. There's no specific way. Yeah, there's no specific way. You can replace normally, you can get dummy variables, you can create extra columns. So many ways. Yeah, you just need to read up on it. So right now, Richard has an AUC score of 0.842. So meaning he has improved much more from the last time. That means we'll go to the leaderboard and check where he is now. So if you check it with no feature engineering, Richard has moved from position 339 to 246. So from 246 now, let's check where he's going to be. Okay, so from 246 with no feature engineering, Richard is in position 211 right now. So if you check it now, out of 851 data scientists, Richard is 211 on the leaderboard with not doing so much work. Let me remind you, no feature engineering, no hyperparameter tuning, no proper EDA and understanding of audio features in the data set and the rest. So yeah, like I would say, may the best model win. Feel free to explore and do many more. So I hope some guys would implement these things in R. Yeah, I hope. Yeah, so this notebook, I would download it and share it to you guys. Yeah, but let me remind you, whatever you do or submit, there will be a validation call from DSN for you to, for you to prove that yes, you have done it. Okay, so thank you very much. That's all. Thank you. I hope, for those guys that asked for the machine learning preview class, I hope we did justice. Thank you. Yeah.
Hello, everyone. Marvelous. If you want to speak, you can go ahead and speak, please.
No, I was just thanking Mr. Temilola. You can go ahead, ma.
Oh, okay, no problem. I think I'll do that on you guys' behalf. I don't know if it's still in class, but yeah, Temilola, thank you so much for a very